a slightly different take on this r cos x plus alpha kind of question here because we're dealing with the velocity and time, but it's the same sort of setup. So to try and express v in this form, we've got our addition formula for cos. And I can take this and I can basically multiply both sides through by r, which is the same as times in each term by r. So therefore, in our case, it's going to be r cos t minus alpha is going to equal r cos t cos alpha. Now, because there's a minus, I'm following the bottom one, so it's going to be plus r sine t sine alpha. And I'm going to try to set, this is an identity, and then I'm going to try and set it equal to our 12 cos t plus 5 sine t. So what we can do here is equate coefficients. This is true. This is an identity. It's true for all values of t. So it must be that this cos t here is the same as this cos t. And therefore r cos alpha is equal to 12. Another way to understand it is that we could, for example, set t equal to 0, and then this term would disappear, and this term would disappear, and then you can, or they would become 1, and then you can get it from there. So that's why you can equate coefficients. Sine t and sine t, so we do the same over here. Our sine alpha is 5. There's a couple of ways of dealing with it here. One that I've become like, quite happy with when when I'm doing it in my teaching is to basically rearrange what the first one. So cos alpha is 12 over r. Let's label this alpha, and then this is going to be 12, and this is going to be r. We can do the same over here. Sine alpha is 5 over r. We've created ourselves a little triangle from which we can see that tan alpha is equal to 5 over 12. I can get alpha from that. The other way to do it is to divide the equations, and you might just be happy enough to do that. Divide the bottom by the top, because then you'll get tan alpha is 5 over 12 that way as well. Just make sure you calculate this in radians. So we get 0.39479. And the nice thing about this method is we also get r really quickly. We can see we can just use Pythagoras, 5 squared plus 12 squared, square rooted, which is actually 13. So the other way would be to square the equations. R squared cos squared equals 12 squared. R squared sine squared is 5 squared. Add them together. The sine squared plus cos squared cancel out. But just sort of flows naturally from this triangle here. Therefore, we're basically done. We can say that V is equal to 13 cos t minus 0.3948. Hence find the two smallest positive values of t for which p is moving in either direction with a speed of 3. So basically it's saying when is v going to equal 3 or minus 3. But I think what we should do is just draw a little sketch of v to completely understand this second part. Okay, I'm going to draw a really small graph of cos. So when I draw this one instead, it's gonna be a stretch. So actually this could just be 13, b equals 13 cos t. It'd look the same. It would just go through 13 instead of minus 1. So what happens when I do this transformation? It's gonna be it's inside. So this is my f of x, then this is gonna become f of x minus 0.3948. So it's going to be a translation in x by 0.3948. Therefore, it's all going to just sort of shift forwards like this. And it's going to be coming down like that. Okay, it's not absolutely integral to get it perfect, but I think it helps. So we're looking at when v is equal to 3, and therefore this is going to be my smallest t value. Um, and then my next one is going to be when we hit minus 3. So here, that's all I'm interested in actually, t1 and t2. So for t1, we're going to get 13 cos t, let's call it t1 there, minus 0.39479. I always use the full value at this point, even though we rounded it here, but get back to using the full. I mean, we're working to enough accuracy if we give our final answer here to three significant figures. So that is going to equal 3. We can divide through by 13. Okay, and then do inverse cos of that. 1.3379. Okay, so T1 is 1.73. And then for T2, it's going to be very, very similar. Kind of tempted to not even show my work in. We're just going to get, I will, same thing, but it's going to be minus 3 over 13. Sorry, let me just write that down. 1.8036. So 2.20. Brilliant.